Okay, our new section 2.3 is called the Fundamental Theorem of Variation. And you obviously have to learn it or learn its shortcuts in order to be able to use it. So that's our goal today. It'll be a little different. I'll be asking you to write some things in your notebook, come to class ready to use those, and share. So here's the first one. If you could copy it, and in that, you can see we have the original value. You're going to pick one, doubled, tripled, quadrupled value. So as an example, if I chose x to be, my original value is x, so let's say my original value is 3. So then I can say, okay, doubling it, 3 times 2 is 6, tripling it, 3 times 3 times 3, okay, not 3 times 3 times 3, 3 tripled is 9, and then quadrupled would be a 12. All right, so if my x value is doubled, then my x value is tripled, and x value is quadrupled. So times by 2, times by 3, times by 4, normal. So now if we take those x values and plug them into this equation, that's what we want here. We want what is that y value every single time. So you go and do your math on the value you chose, and it's best if everybody has a different x value. So try to pick something independent and come up with those values. Once you have those values, the only other thing I would like you to look at is compare and answer the following questions. What happens to your y values? So this far column is what you'll be looking at. What happens to y? So in here, okay, what happens to y when x is doubled? What happens to y when x is tripled? So you're always going back and comparing back to what you had is your original values. Okay? So these will be the basis for most of your work, but you're going to compare. What happens to y when y is doubled? Well, then you got to compare it back to the original. What happens to this number? Okay? When it's tripled, well, you're going to compare it to that number. So I need some discussion points. So do the math, figure out what's happening. Don't tell me it's just going up, because it's a little more than that. So make an observation, make a guess, calculate it, and be ready to discuss that. The second slide is very similar. And that slide starts out with a different looking equation. It is now one of our inverse equations, 1 divided by x cubed. And so if you do that, again, I would stick with the same values you used last time. So my number was a 3, so my original value is 3. My doubled version was 6. My tripled version was 9. And my quadrupled version was 12. And again, you're going to get a y value in each of these. I would highly recommend not choosing the decimal version. So in the first one, for example, if I was calculating it, I would just write 1 divided by x is my original value, so 1 divided by 3 cubed. I can look at that and say, well, 3 cubed is better known as 3 times 3 times 3, or 1 over 27. I would leave 1 over 27 on my paper, or whatever your number is. You need to pick a number different than 3, and not go to a decimal. So again, fill this in and come with those numbers filled in on your table for discussion purposes. It'll make it so much easier. Then, as we did in the last one, ask yourself those same questions. What happens to y? So you're going to stay right here in this column, and you're going to look at those different values that you came up with. What happens to y when x was doubled? So you're always going to compare back to your original. So what happens to this y value? Its answer, that'd be the doubled, and compare it to that. What happens to this value when it's quadrupled compared to the original? You will be able to tell me something. Do not just tell me that it gets smaller. You should be able to tell me more than that, more detail. So if you can, then you'll notice on each of them some different values coming up. And I'm just going to leave it at this slide because this is the fundamental theorem slide. You can take those notes down. That's what it looks like. That's the calculation, the algebra that happens. But one of them is definitely direct, and one of them is definitely inversed, okay, or indirect, your choice, as we talked about. And if you can do that, then when you come to class and talk to me about what happens and what effect it has, then when you come back to class, we're going to be able to do an activity here on this sheet that will find out who really understands the fundamental theorem and who needs a little more practice in it. So be careful. This is just the generic theorem, but these two sheets that we talked about, the inverse version and the direct version, need to be filled out, and you need to answer what happens to y when x is, and you could say doubled, or I might say when x is tripled, or when x is quadrupled. Okay, those are all individual questions that I could ask. What happens to y when x is? So if you can answer that for both this slide and the one with the inverse right behind it, those three questions, you're going to be ready for class. If you don't have them, obviously I'll know that you didn't watch the video. All right, that's all you need for section 2-3.